everyone, and welcome to our video on graphing a shifted secant curve. So we just did one where we did cosecant, and it really was just do a sine curve. That is similar here. We want to do really just cosine. Okay, and then eventually come back to it at the end to say, oh yeah, it's definitely secant, just finish it off. Okay, so on this curve, what we're really doing is negative, y equals negative cosine of 2 pi x plus pi halves in parentheses and then minus 3. However, this one's not in the form. What we need is to have it with a bracket. Remember that whatever is attached to x is instantly factored out. Okay, so the 2 pi is factored out. And then x plus, we'll leave a space, x plus something, and then the minus 3. Okay, because this 2 pi is distributing it back in to give us those two. Okay, so we can see it instantly with the first one. 2 pi times x, yeah, is that. I'm just bolding it. And then we need to figure out, well, what goes here? Well, there's different ways to do it. We can think of it right now as the multiplication. I say that we need 2 pi times something. Okay, so 2 pi times something. I'm just going to do a box. Here's my scratch work. 2 pi times something should be pi halves. And then we could solve this, okay? And I just did a box. You could put a letter in if you want to, like a regular equation. But I'm just going to say, well, let's divide by 2 pi, or which would be multiply by the reciprocal, multiply by 1 over 2 pi. And that way we'd get that box by itself. So whatever that is equal to, okay, so the pi's cancel. And then I would be left with 1 in the numerator. 2 times 2 is 4. Okay, so it's saying that empty spot should be a quarter. And then now double check, distribute. Notice 2 pi times 1/4 is pi over 2. So it is a match. Okay, so it's a little bit of factoring. Factoring is important for us. There's maybe different ways to do this style problem where you don't factor, but I don't recommend it. I would try to get used to some factoring because it's more powerful for lots of things in math. All right, so now it's in the correct form though. Now we start picking it apart. We've got a is -1, which means the amplitude is still 1, but that -1 is important. I'm going to make a side note. Remember that it will reflect across the x-axis. And then we have our b value is 2 pi, which means our period is 2 pi divided by that 2 pi. That's the same thing divided by itself. So that's 1. Okay, so we have the amplitude is 1. We also have the period is 1. Okay, and I just put those together to box them. And then we have the phase shifted stuff. Okay, so we've got the phase shift. So that's a -1/4. Okay, because it's currently plus in the parentheses, so the phase shift will be to the left. And then let me do this one in green. This -3 is a vertical shift. So phase shift is horizontal as well. Vertical shift, they don't have a special name for it. They just call it vertical shift. The vertical shift is -3. So we'll come back to the purple and green once we have the full non-shifted graph first. Okay, so let's get the non-shifted graph. So we've got our cosine curve. It is reflected. And so I'm just drawing my generic reflected cosine curve. There it is. And we can mark our y-axis. And then we can mark our x-axis. Okay, so the period is 1. So here's 1. And then half it. That would be 1/2. Half it again, or multiply the denominator by 2, would be 1/4. And then times this one by 3, which is timesing the numerator by 3, which is 3/4. And then I like to put the 0 there. Okay, so it's all ready. Okay, so that's the non-shifted one. Now we just do our arithmetic. Okay, so I like to do the phase shift first because it takes the most time. We've got 0. Actually, let me do it in blue, sorry. Okay, so I'm taking my important x values there. Let me erase. Let me label. Okay, so we're doing the phase shift. And I want to label my x values just in a table, like go vertical. So 0, 1/4, 1/2, 3/4, and 1, and they need to all get subtracted by 1/4. So the phase shift is to the left, so minus 1/4 to all of these. There we go. And then let's solve these. Okay, so 0 minus 1/4 is negative 1/4. 1/4 minus 1/4 is 0. 1/2 minus 1/4, well, we can fix that real quick. Let's get the common denominator. Okay, so 2 minus 1 is 1, so this is 1/4. 3/4 minus 1/4 is 2/4, and that simplifies to be 1/2. 1 minus 1/4 is 3/4. Okay, so those are our new important x values. Now that we've got our x values, we want to get our y values. That's the vertical shift. The vertical shift, I usually just put right on the y-axis over here. I don't need a full table and just say, oh, I need to subtract 3 from those 3 important points. And I'm going to put a star with the one that was with 0 because that's where the new axis will be. Okay, so let's give ourselves plenty of space. I think that should be good. And then I like to label the vertical shifts first. Okay, so we're going to go down 3. And I'm instantly putting in that new axis. So this is the new x-axis in the green. And then we also need to go down 3 from 1. Well, that's negative 2. And then down 3 from negative 1, which is negative 4. Okay, so those are our new important y values. And then the new x-axis is super important. All right, and then let's do our new x values. Those are the ones in the purple, but plot them on the new axis so to not accidentally misplot future points. Okay, so let's put them all on the new x-axis. Okay, so negative 1/4, I'm going to say is about here. And then 0. And then 1/4. And then 1/2. And then the last one, 3/4. And I think I did a good job making them equally spaced out. Okay, and then now we're going to continue with our transformed graph. Okay, so I'm going to do it in red. Okay, so I had it in blue, but I just want to mark. So this point here was shifted to be this point here. So to the left and down. Okay, so the 5 important x coordinates are telling us where to put those 5 important x coordinates from the left graph converted to the right graph. Okay, so there's that one. And then the next one, that's on this x-axis. So that means it should be on the new x-axis. So here it is right here. And then our peak on the blue graph should have the peak at x equals 1/4, and then at negative 2 for y. Our next point is back to the x-axis, which means we're back to the new x-axis. And then our last point was down below. This one should also be down below. Okay, so there's our shifted cosine curve, or at least the dots. And then now I'm going to do a dashed line. Okay, like that. So it doesn't have to match exactly like the blue one to the left. So this one is a little squashed. That's okay. Okay, so remember, if it's, as long as it's labeled well, it's going to be good. Okay, and then now we've got our strategy to get the secant curve. So with secant, we find where the cosine curve goes through the x-axis, except it's been shifted. So it's where it goes through the new x-axis. So the asymptotes are through x equals 1/2 and x equals 0. Okay, so these that's why that new x-axis is the more important axis. And then we find the peaks. There they are. And then from those peaks, we draw away from the cosine curve to the asymptotes for the final secant curve. There we go. Okay, and so there's one full period of our secant curve that's been shifted. We can label the points. Okay, so for instance, this is 1/4 and -2. This one was 3/4 and -4. And then this one was -1/4 and -4 also. Okay, in case it's getting tough to see, at least we can see, the points and our asymptotes, all of it's labeled to where I think it's clear enough. Okay, so but I think if you try to keep it as clean as you can, you don't need to label those points. We could see everything that's important. Okay, but with that point that's labeled, let's go ahead and check. Okay, so I'm gonna say I'm boxing this to say I think I did it all correct. It's all ready to go in the black ink, and then I'm gonna check. Let's check the 1/4 and -2. So let's do y equals negative secant of 2 pi times 1/4 plus pi halves, and then minus 3. And we always plug it back into the original. Okay, so in case we accidentally messed up somewhere after. So always back in the original. Okay, and then let's simplify. Okay, so the 2 pi over 4, that would be pi over 2. Okay, so we've got y equals negative secant pi over 2 plus pi over 2, and then minus 3. Pi halves plus pi halves is pi. So we've got negative secant of pi minus 3. Well, secant of pi, I would do cosine of pi. Cosine of pi is -1. The reciprocal of that is still -1. So this is negative -1 minus 3, which is really 1, positive 1, minus 3, which is -2. Yes. Okay, so that point worked, and we could check the others as well. Okay, but to save time, I'm going to say I think that's good. Let's move on. If you have lots of time, say on a test, definitely double check things. All right, but that's that. Okay, thanks for watching. If you have any questions, please let me know.